In this question, you have to sketch the graph of each of the following relations and state the implied domain and range. So sketching the graph and also stating the implied domain and range, which the implied domain is the same as the maximal domain, and when you have a graph, it's really from the graph what is the domain and what is the range, and the graph will let you know what the domain and range are by looking at the x values that belong to the graph and the y values that belong to the graph. So the first one, a, f of x is equal to x squared plus 1. So this is a quadratic function, a basic quadratic y equals x squared, which is centered or has its turning point at 0, 0, which is here, and it's upright because it's positive x squared, something like that. And when you plus 1, that just adds 1 to the y values, which in other words moves that graph up 1. So you end up with something like that. This here has a value of 1, that's a y value of 1, and then this of course is the y-axis and this is the x-axis, and looking at that graph you can see that the x values, and the x values, a good way of doing them when you set it out in interval notation is to look for the lowest x value, which is going to be somewhere on the right or left hand side of the graph, and if you keep going that way you're heading off to minus infinity, and if you go the other way you're heading off towards positive infinity for the x values, so round brackets for those two. And the other way that you could write the domain is just to say, well, that's the set of all real numbers. The y values, the lowest y value on the graph is this value of 1 here, and then when you move up on either part of the graph you're heading off towards positive infinity, so 1 to positive infinity, round bracket there. This value of 1 is included, so that means that has a square bracket, so that's the range and the domain for part A. Part B, f of x equals 2x minus 6. This is a linear equation, so the gradient is 2 and the y-intercept is minus 6. So sketching that, yeah, that's y, that's x. It's always good to have to write the x and y axes in, and that way you're never likely to forget them and lose marks for not having them labeled. So y-intercept of minus 6 is somewhere down here, positive gradient of 2, so it's doing something like that. So that there is minus 6. This way the graph heads off towards minus infinity for both x and y, and this way it's heading up to positive infinity for x and y both. So you could say the domain, again you could write it like this, or you could just go all reals, and the range is also all reals. C, x squared plus y squared equals 25. This is the equation of a circle, which is always in the form of x or x plus something in a bracket all squared plus y plus or minus something in a bracket all squared is equal to some positive number here. It's always the equation of a circle. So when it's x squared plus y squared, it means the center is 0, 0, and this number here is always the radius squared. So the radius, little r, is equal to the square root of 25, which is 5. So that means this circle is centered on 0, 0, and something like that. And there's y and there's x. And radius of 5, just have to pretend that's centered on 0, 0. It doesn't really look like it is. So the radius of 5 means from 0, 0 to this point here would be 5, so the x value there would be 5. This would be a radius as well, so that means that x value is minus 5. And again, this is a radius and that's a radius, so that's going to be a minus 5 down here. And this y value up here would be 5. So from there, you can see the x values go from minus 5 to positive 5 inclusive, so those all the points on the circle are included, so those two x-intercepts there are included, so you're going to have square brackets here like that, and range similar values from minus 5 here up to 5. So if you were to trace out the graph, the y values would be anywhere between -5 and 5, and the x values would also be anywhere from -5 to 5. So that's the domain and range for that one. And square brackets again, because as I mentioned, the x-intercepts and y-intercepts are included, and all the values in between -5 and 5. Part D, the set of x and y values such that, or the set of points x comma y such that y is greater than or equal to 2x plus 1. This is just notation. It's a different way of writing a function or a relation, and it doesn't really mean anything about how you're going to work it out. You're going to work it out in exactly the same way as if it had been just y greater than or equal to 2x plus 1. So when you have to sketch an inequality like this, the best thing to do, first of all, is sketch y equal to 2x plus 1, which I've done here. Y equals 2x plus 1 is a linear function, gradient of 2, y-intercept of 1, so that's positive 2, positive gradient, and passing through y equals 1. When you have to sketch an inequality, the graph is going to be a region of the plane. It's either going to be points above the line, either including or not including the line, or points below the line, either including or not including the line as well. And in this case, because it's y greater than or equal to, it's going to include the line, so you would leave the line solid to show that the line is included. And because you want y greater than this, the region that you want is the region above the line, and that's going to be most of the time when it's y greater than or equal to something, or y greater than something. And the reason why is because when you sub an x value into here, you get a number eventually. And if you want y values that are greater than or equal to that number, which is a y value, then you want y values that are more than that number. So if the number, well, this number here, when x is 0, y equals 1, you want y values more than 1, which are going to be y values above that point. So therefore you want points above that line. And if it was y less than, you would want points below the line. And now to work out the domain and range from that graph. So the domain, the lowest x value first. So no matter how far down that line goes, the region you want is going to be the left or on top of that line. So that region kind of heads that way forever. So that means that the lowest x value is definitely going to be minus infinity, and with the round bracket. And then the highest x value is going to be when you get to that line. So if this line keeps going in that direction towards the right, eventually that line is going to be approaching infinity in the x direction. So even though at some point you get to that line, the line still goes beyond that point, and so the x values keep going further and further to the right all the time, which means they are all heading towards infinity as well. So the domain is from minus infinity to infinity, or you could write all reals. So every possible number in the number plane, or the x value, let's just say that again, x can be any number in the number plane. And for the range, you could say a similar thing. So that line keeps heading upwards, and you're always going to want the part above that graph, which is going to go, and including, but above as well. And that's going to be always heading towards positive infinity in the y direction. So that's going to be the biggest y value. So I'm kind of working backwards here. So that's the biggest value. So the lowest y value will be when you get to the line, but because the line keeps going, you're going to have an even lower y value as that line keeps going. So because it never stops, that means that the lowest y value is always going to be infinity, minus infinity, I mean. So I hope that explanation makes a bit of sense. So you could have either of those two for the range, so all reals, or minus infinity to infinity for the range, or for both of them actually, domain and range. So I hope that makes sense, that little explanation. With E, I've just drawn the sign the wrong way, so y less than, it's because I was looking at the wrong question. Y is less than x minus 3, so sketching that. And again, linear, y and x, y-intercept of minus 3, gradient of 1, so positive gradient, doing something like that. There's minus 3 here. And you want y values less than whatever the value of that becomes. So you're going to want y values underneath that straight line, like that. And because it's not equal to, it means you don't want the points in the line, so you need to dot them out. So there's the graph of this relation, and for a similar reason to what I mentioned over there, the domain for this one's going to be R, and the range is going to be R as well. So again, the domain, lowest y value, lowest x value, that line keeps heading towards the left. Even though you get to that line and the value on that line is not included, the line can keep going further to the left, which means the x values keep going further to the left as well, even though they don't hit that very last point on the line. But there is no last point on the line because the line keeps going forever. So therefore it's heading that way forever, and it's doing a similar thing heading that way forever, which means the domain has to be all reals, and similarly with the range. So that's how you do, or a way of doing these questions. And a couple of things to mention. I need to make sure I put arrows on the graph because that would indicate the graph keeps going forever. And didn't really say up here, sketch the graph and show all intercepts and all important points. So I haven't really labeled those. I've really just found key points on each graph that enable me to, or did enable me, find the domain and range easily. So needed to find this minimum point here to figure out the range, and also for this one here needed to find those x and y intercepts to find the domain and the range. And this one you've just got to look carefully at the graph. And having seen this now, as long as the domain is not restricted in any way for this question, in other words, there's no thing saying here f, for example, f dot dot some domain mapped onto R for some inequality function. As long as there's no restriction by something like this, then the domain for this kind of question is going to be R and R. And I hope all that makes sense. These two are definitely the hardest to explain, so I hope that my explanation has made it clear for you. And that's about it for this question, and I will see you in the next one.